Welcome to today's webinar. Today we show you the design of a glass railing in RFEM 6. That's now possible with the quite new add-on glass design. My name is Andreas Herold. I'm responsible for marketing and PR in the company Dlubal Software. For instance, technical content of the website, the newsletters, German and English webinars, and so on. I will be the moderator today, and I will answer your questions during the webinar. My colleague Ulrich Lex will be the presenter today. He's responsible for the development of the add-ons glass design, construction stages analysis, masonry design, and the main program RFEM 6 as well. And he works also in the customer support. Okay, then I say some words how you can ask questions. At first, I switch off my camera that you can see the full screen. Just press that button with the question mark, then enter your question in that field, press send, and I will receive your question and I will answer you. The other way is to watch the entire webinar and then email your questions to info@dlubal.com. Okay, that's at the moment all from my side. I hand over to Ulrich. Ulrich, it's your turn.
Thank you very much, Andreas, for your introduction. Also from my side, hello to today's webinar of design of a glass structure in RFEM 6. Today we want to take a look on a railing system of a balcony, maybe, how we can do the modeling in RFEM 6 and compute this structure. We want to take a look at some variants, maybe on the failure of one surface or on the failure of one layer of a surface. And at the last thing, we want to take a look at the design and documentation in RFEM. That's all for the series. Then we want to switch to the program. And at first we want to take a look at the system. The system should be a surface which have on the top side a handrail in steel, and in the downside it's a cross section. The surface is clamped in the cross section. It's, I would say, an easy system, and this we want to create now in RFEM 6. So we want to switch to the program. I've already prepared the structure, the surfaces that but I won't show what I did everything. At the first thing, we take a look at our base data. When we now want to design a glass structure, then we had to go to the add-ons and we had to activate our glass design add-on. The second add-on what we need is the steel add-on for the handrail. And to take a look at the variants, we need the add-on construction stages analysis. When we activate glass design, then we can take a look at the standards. There are currently two standards, or one standard and one non-standard is implemented. It's on the one hand the DIN 18008, and we can do a check of stresses without any standard. So today I want to take the DIN standard. So I have also to set for the load classification the DIN standard 2. here we can continue with OK. What I did for the preparation 2, I create some new materials. In our case, I want to use a float class, terminally touched float class. It's already implemented in the material library where we can choose this, and it is defined in RFEM. Also, I have defined a foil PVB, what I want to use. When I now want to create a new class composition, then I have to create a new thickness. When we go to the thickness dialog, then we have now the possibility to choose the thickness type class composition. This class composition is similar to multi-layer. When we choose this, then we get a new tab where we can define the separate layers. In our case, I want to use class layers with thickness 10 millimeters, a foil layer with thickness 1.52 millimeters, and as a third layer, a class layer with thickness 10 millimeters. This is all what we have to define in the thickness dialog. As the next step, we can create our structure and we can define our surfaces. For the surfaces, we have now a new option to assign the design properties for class design when a thickness with class composition is defined. Here we have two new tabs, one with design configurations. We have two different design configurations, one for ultimate limit state and the other for the serviceability limit state. We can take a look at it, take a look at it. The design for class is on the sigma 1 stress, but we can choose, if it's needed, also other stresses. There are special settings for the standard too. Additionally, the standard parameters for design values are in this configuration too. Today I want to use the default values. Also for the serviceability, I have defined some default values for default limits. And I can also define a limit for a cantilever service. There is nothing in the standard, so I can define my own limit. Today I do not want to check the serviceability limit, so I do not have to define it. And the last tab, we can define the settings for deflection. I have to define which system I have, maybe a cantilever, and a reference length. I can use also. I can set it also manually or automatically. So this is everything we have to, or we can define in the dialog for the surfaces. I created here some surfaces. One surface is my on the upper side, and two additional surfaces because of the because here I want to add the supports and the clamped system. I could also define here only one surface and maybe use only on this line line support. It's up to the user how the system should be. So when we have defined a thickness with glass composition and some surfaces with the glass material, glass composition, then we get now a new type for design. It's called glass composition model. These composition models are generated automatically according to the geometry and the used thickness. And here you could do some additional settings, special settings for glass design. In the current state, we only can choose if we want to use shear coupling between the different layers from the foil. As default value, we used uncoupled. This means that we get a stiffness matrix for two separate glass surface and use this in calculation. We also could change it to coupled. Then we get a higher stiffness matrix and use also the foil in a equivalent, maybe equivalent thickness. So, but we want to use today the uncoupled system. These are all the special things for glass, so I can continue with my system. At first, I want to define my supports. As I said, I want to have a clamped system in this part downside. So I edit these surfaces and want to add a support. I want to create a new support condition in locally UZ. Okay. And additionally, I want to use in global Z direction support in the line downside. Okay, continue with OK and choose all the lines. Prevent to okay, I can to modify the view a little bit. So with this easy click right on the support. Okay. As a second thing, I want to add the handrail. Here I have to choose all lines. I want to edit it in this case. I want to add a member. Member type with beam. I want to choose a new section from the library. Here I created in R section this handrail, what I want to use, and load it directly from the Dlubal Center. So I use here steel material as material. Continue with OK. OK. And OK. And now I have defined here my handrail. On the wall side, I want to fix this handrail in global X direction. So I add here a node support. In global X direction. Okay, okay. Okay. So when I do the modeling in this way, then the glass surface and the handrail are fixed connected, a fixed connection between both things. I would say it's not the best thing, because here I think always only forces in global Y direction should be transferred. Here I can show the local axis of members of lines. It's a local Y direction too. Where I want to transfer the forces. The other directions I want to release, because it's maybe connected with the silicon or something else. So I do not think that there is a fixed connection between. So I can do this with a line release. What I want to create here, a new line release. I choose the lines where I want to assign it. And I create the new line release type. Here I want to use a fixed connection in Y direction. And for the other direction, I use a low spring constant, only not to get an instability. Then I continue with OK. And at the last step, I had to define the released objects. Here I want to release the surfaces. 2, 3, 4, and 5. OK. Continue with OK. The line releases are displayed with such a rectangular. You can also take off this rectangular thing. Here, line releases. Okay, as a next step, I can take a look at the FE mesh. Here I have to take a look at the FE-mesh settings. As a default value here is 0.5 meters. It's a little bit too rough for glass structures, so I want to use here 5 centimeters, for example. Can continue with OK and apply, so that I can see the FE mesh. It's really regular, so it would be okay, I would say. Only downside for the supports, I think it's too rough, so I can assign here some FE mesh refinements for these surfaces. I can edit these surfaces, use here a mesh refinement, create a new one, maybe the half of the regular mesh, continue with OK. OK, and take a look on the mesh again. Now it's better, I would say, so it would be okay for me. As the last step before the first calculation, I can assign my loads. Here I want to create a new load case. The first case is the permanent load. In our case, we could ignore the permanent load, but I want to let it as it is. So I create a new load case with an imposed load. Here, when we use for classification also the DIN standard, then we get here a new tab for the load duration, where I can choose permanent, medium, or short-term load, and could switch it manually. So I want to use imposed load. OK, and create here a new member load with 0.5 kilonewton and assign it to my members. So because of the support in local in global X direction, I want to ignore now the loads on these members on the side. I won't only take a look on the members in front, but it's only a simplification for this presentation today. This is acting in negative direction and in Y direction. Continue with OK, and we will see here our loading. So now the modeling is nearly ready, and I can try to compute my first load case. It's only to see if something is missing or if the modeling is okay. So it seems okay. We get I would say a nice deformation. We see that there is nearly no force in the handrail. The force has to be transferred via the glass surface to the support. And this is what we want. Okay, so now our modeling is ready. Then we can take a look on the different stages. For such a system, it is required in the standard that maybe one surface is failed, or even one layer of the glass composition is failed. This we can take a look with our construction stages. Therefore, I want to add here a new construction stage. I want to activate in the first stage all the members. I want to activate surface. I want to activate here all surfaces. Okay. I want to activate all nodal supports. And I want to activate all line supports. The surface supports are automatically activated when the surface is active. So this is everything in the first stage, because in the first stage I want to design the structure as it is. Now I can copy this first stage, and in the second stage I can take a look when maybe the surface on the left side are not active. So I can deactivate surface 1 till 3. I have to actualize my line supports. And this is my second stage. In the third stage, I want to take a look what happens when the surface in the middle is not active. If it is possible with my handrail to transfer the force to the right and left side of the surface. So I deactivate surface number 4 till 6, actualize my line supports. Okay. And as a fourth stage, I want to take a look when only one layer of the surface is inactive. Here I had to continue with OK, and I have to additionally create a new thickness. So when a glass composition is defined and the construction stage add-on is activated, then I have the possibility to create a thickness type vase thickness. This vase thickness has a parent thickness. This is in my case the glass composition. And here I could say that not all layers are active. I can deactivate some layers of this parent thickness. And here I want to take a look when one glass layer is failure and only one glass layer is active. Here I can continue with OK. Then I go back to my construction stages. I copy my first stage. And now I can say, okay, on the surface, here all surfaces are active. But for surface maybe 4 till 6, these surfaces should be modified. The thickness should be modified. I do not want to use the glass composition. I want to use the the vase thickness in this stage 4. I can continue with OK. And now these stages are created. I can take a look on these different stages. The first stage is the complete system. Then the left surface is not active. The surface in the middle is not active. And then the first 4th stage, I only use a different stiffness for the middle surface. So for design, I had to activate here for the different stages the load cases. Here always all load cases are active because it's always a stage from beginning. Okay. Then I have to create some design situations. Here automatically our design situations according to standard are generated, where they are active for steel design and glass design now. Also for SLS, here I want to not to use the glass design in this example. So now I have to assign this construction stage to my design situation. I can do this when I use a combination wizard. I want to edit my first combination wizard. Here I want to use geometrically linear calculation, and I want to consider here an initial state and want to use here my stage 1. For the other design situations, I can prepare it now here. I want to copy it. I want to use stage 2. I want to use stage 3. For the 4th, I want not to do it. It's because save time now. Okay, want to continue. Now I have to create a new design situation where I use the second wizard and can copy for the third wizard. What is happening now when I do these settings? Then I get load combinations created with always 2 combinations, load combinations. One load case 1, load case 1 and 2 for stage 1. The second is for stage 2 and the third is for stage 3. Here I miss something is missing. So I have to take a look at the stage 3 here. Okay, now I have for stage 2 and for stage 3 here my load combinations. For the load combinations, there automatically is the load duration assigned. It is according to the settings from the load case. So I take a look, but we have all settings what we have to do for this load and load combination, so we can continue with OK. As the last thing before calculation, I want to do the settings for the handrail. I want to check the stresses for the handrail, so I can take a look on the members dialog. The same as for glass, we have here design properties for steel design. We have here tabs for design types. I do not want to consider effective length or something else. I only want to do stress analyze, no stability analyze. So I deactivate stability analyze. And have not to do something else. Continue with OK. I can set here for steel design in the settings only the ultimate limit state and continue with OK. That's all we have to do for the modeling, for the input. And as a last step, we can continue with calculation of the system. I use calculate all, then the stresses are computed and the steel design and the glass design are computed too. At the calculation dialog, you can see what is computed right now. You can see the iteration things. And then we get the results for the system. So I want to take a look on the different stages. Here, maybe for the stage 1, I have my load and all surfaces active. For stage 2, I have all my load, only these surfaces are active. And for the third, the middle surface is not active. So the results of the add-ons are directly in RFEM itself. So we have here in the navigator for the results now 3 things. One thing for the static analyze results. These are deformations and stresses and so on. And we have the results for the glass design, the ratio, and these things. So as the first step, we want to take a look on the deformations. Maybe deformations in CU2. We have here 21 millimeters, like, or here maybe 14 millimeters for the SLS combination. When I take a look on the other stages, then I get 38 millimeters deformation in stage 2 and about 35 millimeters in stage 3. I think it's okay because the load is transferred via the handrail and the glass surfaces has to act with the additional load. So here we can take a look also on the stresses. On the stresses, I can take a look on the principal total strains stresses. Sigma 1, I can choose the layer side, maybe on the top, middle, and bottom side. This side is defined on the local Z axis, where the local Z axis goes out from the surface. This is the bottom side. So our maximum stress should be on the top side of the surfaces. So I take a look on the top side, sigma 1, and get here a maximum stress from 23 Newton per square millimeters. When I take a look on the glass design results, then I have here the ratio of the maximum. I can take a look on different things. I can take a look maybe only on one design situation, on the first design situation, and here not the ratio envelope. Then I can choose the layer side or the layers. And see and can do here different settings what I want to see. The maximum ratio for the stage 1 is here 26%. It's on the top side from this surface. So with a double click on this result, I can take a look at the detail results. Here I can show the formula, what is computed. I can show, I get displayed the design check, from which part in the standard it is. I can take a look on the sigma 1, 23 Newton per square millimeter, when we remember before. I can print these results also to the printout report. I can here say print graphics to printout report, continue with OK, and we take a look at it later. Here I can take a look on each point in the surface, the results we have done. Additionally, I can choose these details in with this button. The button right next are the details over the thickness. When I choose this, I have here the possibilities, a result diagram and a surface point. I can choose here also the stresses, maybe when we remember sigma 1, then I get displayed the stresses for this point. This sheet we can also print to the printout report. Print graphics to printout report. I can do some settings, continue with OK, and close. Downside, we have different other result tables where we can show the ratios by loading, the ratios by material, the ratios by thickness, or we can choose the governing results where we can where we have the forces, the moments on the place of the design check. So when we take a look on our different stages, then we can see for stage 1, the ratio is about 26%. The ratio for stage 2 is about 78%, and the ratio for stage 3 is about 43%. So I would say it makes sense to take a look on these different stages too, because the ratio is much higher as the default value. Okay, that's all from this side. One thing was we take a look at it is on our handrail. Here I only did an stress analyze. It's not really in detail, but only to take a look if it's overloaded or not. Here we can take a look at the different stages too. The maximum is about nearly 50% for stage 1. It's a little bit over 50% in the stage 2, and it's about 65% in stage 3. So everything is okay. This handrail is okay for this structure. So as the last step, we can take a look at the printout report. When we open it, it will be displayed. So here we get a lot of details, a lot of tables, what could be modified individually. It's how the user wanted or needed. You get the results for the different stages, what is modified in the different stages. We get information about supports, everything in tables, and we also have our results here, our pictures, what we printed into the printout report. Here you can move it to another place where you want, and it's up to you to print here more pictures or an overview. You also get the formulas, what we printed to the printout report. Okay, this is all from my side, what I want to show you. So hopefully you enjoy the presentation. I want to say thank you for listening, and I want to give back to Andreas.
Thank you, Ulrich, for your presentation. I have an additional hint. You can book our online courses. At first is RFEM 6. That's a course for beginners. Then we provide the Eurocode 2 course for the design of reinforced concrete, and Eurocode 3 for the steel design, or in RFEM 6. For more information and the prices, just scan the QR codes in the middle or press the links at the bottom of the page. Okay, that should be also all from my side. I thank you for your attention. Thanks to Ulrich for your presentation. I wish all a nice rest of the day. Bye bye.